In this video, I'll demonstrate how to find general solutions of differential equations through a technique called separation of variables. Check out the differential equation dy over dx equals x times y, and its slope field is plotted to the right of it. We want to solve this differential equation for its general solution using separation of variables. Okay, so in order to show the technique, I'll do it on the side here. We want to start with the original equation, dy over dx equals x times y. And we're going to want to get x's on one side and y's on the other through algebra. So the first thing I'll do is multiply that dx to the other side. And now I got to get the y away from the x's. So I'll actually divide both sides by y. Now we've truly separated the x and y variables, each having their own side. Since we've done that, we can integrate both sides. We'll find antiderivatives for each side. And we can put a plus c on one of the sides. We don't have to do both sides. Finally, what we'd like to do is solve for y. We need to undo the natural log of a variable. And the way that we undo natural log is by letting each side of the equation become the exponent of a base of our choice. In this case, e would be the right choice to cancel with ln. That means these will go away, and we'll be left with y equals e to the x squared over 2 plus c. Now, believe it or not, we can actually further simplify this. And the reasoning behind what I'm about to do next is this. We have addition of exponents here. So that would mean we could change it to e to the x squared over 2 e to the c by rules of exponents. And so this e to the c is actually itself just a constant. And so if I were to call this guy c1, constant 1, then I could rewrite what I have here into e to the x squared over 2 times some constant c. And so my final answer will be c e to the x squared over 2. That is the general solution. Okay, now we can go back. And we found that the general solution was y equals c e to the x squared over 2. Let's go to Desmos for just a minute and let's plot those functions and see what they look like. First, I'm going to show the slope field of this differential equation. And now what I'm going to do is I'm going to write in the general solution that we found. I'll use the slider to see what kind of curves it makes. Does it seem like the functions have some relationship to the slope field? The slope field represents the slope of the solutions. All right, so now we're asked to find the particular solution that passes through a point 0, 0.5. Let's start with the general solution. And all we have to do is determine what constant c would work for going through the point 0, 0.5. So let your y be 0.5. And let your x be 0. So clearly here, c is 0.5. That means that the particular solution is going to be y equals 0.5 e to the x squared over 2. Let's go to Desmos and plug that in. Change our c to 0.5. Is it true that this solution goes through the point 0, 0.5? Just to be sure, we can plot a point. It does. There's the point 0, 0.5, and our particular solution goes through that point. That's what we're looking for. Okay, so let's go ahead and sketch in this picture our solution curve. And here's our point. Now it says find the value of y when x is 1. Well, for that, I'll start with our particular solution. Plug in an x of 1. It is 1/2 e to the 1/2. Approximately 0.824. That would be this point right here.